Node and graph, literal or metaphor? Yes, RiverPad really does use a graph-like structure under the hood, not a generic graph argument T data structure you'd implement in DSA class, but a dependency graph built from providers and their dependencies. What is a node? A provider instance is a node. So you can think of like a provider instance is a node in the RiverPad graph or direct acyclic graph. So final user provider equals provider argument user dot next line final profile provider equals provider profile argument for dot. Each provider equal one node. What is an edge? An edge exists when one provider reads another or one instance read another provider instance. So a final provider equal provider argument rep open semi-curly bracket next line final user equal rep dot watch argument user provider semicolon. So that's where the edge is created. The next line return fetch profile argument user dot id semicolon then closing. This creates user provider to profile provider. So that user provider become a child instance of the profile provider and it becomes an edge to profile provider. So yes, nodes equals to provider, edges is the ref.watch, ref.read, and ref.listen. Second, what is a dog and why it matters? Dog equal directed acyclic graph. Directed dependencies have direction, acyclic, no cycles allowed. So the reason the dependencies in the directed acyclic graph is the directed, and the word acyclic is what makes it no cycle allowed because of the memoization. Kind of like with the graph data structure we discussed that implement memoization under hood. So this is what makes it acyclic. So why no cycles? Because A depends on B, B depends on A. Infinite recomputation impossible to resolve. RiverPath enforces dog constraints or memoization. How this builds from your earlier question, you asked earlier about pipeline execution, pointer chasing, CPU cache locality. A dog gives predictable recomputation order because of memoization, minimal invalidation, and then cache friendliness. This is the scene design pressure of CPU pipelines. So avoid feedback loops, maximize locality, minimize stalls. Third, recomputes lazily is not equal react diffing. This is a very important correction. Lazy computation is not react diffing algorithm. React diffing happens after you render. Compares old virtual DOM versus new virtual DOM. It decides what to update in the real DOM. RiverPad lazy recomputation means a provider only recompute if someone is watching it. So if a node instance are watching another parent node instance, example, final expensive provider equal provider argument ref open semicolon bracket next line print argument computed next line return heavy work semicolon then closing. If nothing calls ref.watch argument expensive provider, which is the final provider is, then heavy work never runs, or what is being returned on that function. That's laziness. Is there a code for that? Conceptually, it's like this. Class provider node, open semicolon bracket, next line bool, has listener semicolon, next line value, cache value semicolon, next line list, argument provider node, dependent semicolon, the next line value get, open semicolon bracket, then if not equal to hash value, the dependency change, and then open semicolon bracket, next line cache value equal compute, open and close parenthesis semicolon, that's closing, then return cache value semicolon, closing. So this is memoization plus dependency tracking, not diffing. Fifth, memoize function output, exact meaning. This is the core idea. A provider is a pure function plus a cache. So that's the provider instance or a node. So like this, final answer provider is equal provider argument rep, open semi-curly bracket, next line return 40 plus 2, then closing. Internally, so you have input, the dependency values, then a pure function. So you have the dependency value, check first if it will return the same output, and then it will be converted to a pure function, and then it will cache the output. Since in this case, you have a new output, that's why the pure function is executed. But if it's not, the same value, it will not be executed. This pure function will not be executed. If inputs don't change, output is reused, or this cache output. This is what memoize means. Big correction, redox versus river path state updates. You ask, do you mean it updates only what changes instead of instantiating a new state like Redux? This is slightly wrong in both directions. Redux always creates a new state object, but reuses unchanged subtrees, structural sharing. So it will reuse as well the unused subtrees. Let's say you just update some object or some tree. That's the only one it will update. But for all other part of your app, it will just reuse it. In RiverPad, it does not create a new global state. It replaces only the provider's value. Other providers are untouched unless dependent. So the other providers or other instance currently in the app is untouched. Only the provider's value that change are recomputed. So redox diffing happens at the object tree level. RiverPad invalidation happens at the dependency node level, where your understanding is hand wavy, explicit. Hand wavy area number 1, graph isolation. You understood it intuitively but precisely. Graph isolation means each provider subtree can be invalidated indefinitely. Redux cannot do this without selectors. RiverPad does it by default. Hand wavy area number 2. So to do this kind of like computation in Redux, you need like a selector syntax. Hand wavy number 2. State updates like diffing. Hand wavy area number 2. State updates like diffing. You're mixing 3 different mechanisms. Virtual DOM diffing is React. Structural sharing is Redux. Dependency invalidation is RiverPad. They solve different problems at different layers. Hand wavy area number 3. Backend updates, state, and UI license. Missing precision, backend emits event. Client runtime parses bytes. And then providers cache values. So these bytes in the client will, after the RiverPad or the Dart has been built, it will run in the user space memory. So it will be parsing bytes there, and then it will, that user space running that's already been built will make meaning from those bytes. And the providers caches values. And then we just subscribe to providers. No direct backend to UI pipe exists because it is being converted or parses by the client runtime. The JavaScript to Dart, and then it's up to Dart declaration of transformation to produce meaning on the front end. No direct backend to UI pipe exists. Errors of omission, this matter later. Omission number 1, referential transparency. Providers works best when same inputs to same objects. If you ignore this, caching breaks. Omission number 2, invalidations are directional. When a provider changes, only downstream nodes recomputes. Upstream never does. This is crucial for performance reasoning. So that's the reason why you get, fast performance or you cache the same output is because the code under hood of Dart does not recompute upwards. It only recomputes downward. And also it's structured the way and also how you write the code are actually structured that way. You write the upper level first, the backend, and then all the way to the child, which is the widget. So omission number 3, time is implicit. Reverse path state is a snapshot of now. Redux explicitly models time history. River path intentionally does not. Subtle misunderstanding that would block advanced learning. This one is important. You sometimes think state is a thing stored somewhere. Correct model, state is a value flowing through a dependency graph. This matter for concurrency, optimistic updates, background refresh, partial invalidation, server streaming. If you don't internalize this, advanced reactive system will feel magical. One sentence that fixes everything. RiverPath doesn't manage a global state object. It manages a graph of memoized computations or caches values output in each node instance whose values are invalidated by dependency changes.